and we did some questions on concentration term. Do you have any doubt from the previous class? Any topic or any question? You were not audible. Okay. So I'm going to give you some questions. So we were studying molarity. Can you solve this question? 7.1% weight by volume Na2SO4. Calculate molarity. Let me know if you will be if you will unable to solve this question. Okay, just see 7.1% weight by volume. What does it mean? This is basically 7.1 gram of Na2SO4 presenting 100 ml of solution. Now see what we need to calculate is molarity. This is given, mass of Na2SO4 is given, and you can also see 100 ml of solution. That means volume of solution is also given. So molarity is equal to number of moles of solute upon volume of solution in liter. Again, we can easily calculate number of moles of solute because we have a formula given mass upon molar mass and volume of solution in liter. Now going to put the value given mass, that is 7.1 upon molar mass is 142. Can you calculate molar mass of Na2SO4? That will be approximately 142 ml, and volume of solution in liter, that is 100 ml, and in liter we need to divide it by 1000. Now just calculate it, simplify it, you will get your answer. It will be like 1000 upon 100. Again, if you are going to remove this decimal, 10 will be multiplied in denominator. This all to 0 will be cancelled, and here we will be left with 71 by 142, and it will be 1 by 2, which means 0.5 m, or we can also write 0.5 moles per liter. This per liter. This is the molarity.
Done.
So I'm going to give you another question on the same concept or similar question. The question is basically 49 gram of H2SO4. No, not 49 gram. 49% weight by volume. H2SO4. Calculate molarity. what is the answer?
So it will be 49 into 1000 by 100.
Your voice is disturbed, Hamza. Can you get message me in chat box? See what we have. 49% weight by volume. What does this means? 49 gram of H2SO4
100 grams.
in 100 ml, not gram.
Yeah, 100
Since
ml, sorry.
in denominator it is volume, so 100 ml of solution. After writing this definition, you can see given mass of H2SO4 is given and it is volume of solution. Again, number of moles of solute upon volume of solution in liter, we can write number of moles of solute given mass upon
39.
molar mass. 98 is the mole and 98 molar mass of H2SO4. Volume 100 divided by 1000 in liter. And now we are going to just simplify it. 1000 upon 100. You can see 20 will be cancelled by 20, 49 to the 98, and it will be 2 5 the 10. So the answer is 5 m, or we can write 5 moles per liter. Am I right? That's a good question. If you have any doubt regarding anything, ask me. How do we know 98? So basically, I have done a lot of practices. That's why in sum of individual atomic masses. Sum of individual atomic masses is called molar mass or molecular mass. So what is the mass of hydrogen 1? But here hydrogen 2 hydrogen is present. Now sulfur has atomic mass 32 and only one sulfur is there. So it will be like this. Again, plus the atomic mass of oxygen is 16 and there are 4 oxygen. So it will be multiplied by 4. So it is 2 plus 32 plus 64. When you will add it, you will get 98. Do you know how I wrote 142 molecular mass of Na2SO4?
Yes.
Can you solve it? Molecular mass.
Atomic mass of sodium 22 plus atomic mass of
Sodium 23. Sodium has atomic mass 23 and 2 sodiums are there. So it will be
22
multiplied by 2 plus this is 32 and plus
plus
4 oxygen and
64.
60. So it will be 46 plus 32 plus 64.
64.
It will be equal to 142, right?
Yes.
Very good. Please write it. Are you done with this? Can I change the slide or are you writing?
No, done.
Okay. Now see another type of molarity, that is molarity on dilution. Molarity on dilution. Do you know what is dilution? Yes or no?
Adding H2O.
Basically, what does it mean? H2O.
Mixed
Basically,
with water.
whenever we add solvent in solution, that is dilution. In case of generally we do with water, like if an acid is concentrated and if you want to make it dilute, you will add water. So basically, addition of solvent to a solution or concentrated solution is called dilution. Are you getting my point?
Yes, sir.
Now see, there is a container which has molarity M1 and volume is also V. And here the number of moles of solute is N. This is basically number of moles of solute, and you are going to dilute it. If you are going to dilute it, what does this means? Dilution take place. That means you are adding solvent to dilute it. Okay, and after some time its volume changes to V2. So if volume is changing, molarity will also be changed. Yes or no? If volume of solution will be changed, molarity will be changed or not?
Yes.
Yes, because you know that, just see, molarity has a value, number of moles of solute upon volume of solution in liter. Initially, if it has volume 2 liter, it will be n by 2 molarity. And if it has a volume 4 liter, it has molarity n by 4. So basically, you can also see molarity is inversely proportional to volume. If volume increases, molarity decreases. Are you getting my point?
Yes.
So in short, what I want to say, on dilution, molarity will be changed. So it will be M2 and V2. Now, on dilution, will the number of will the number of moles of solute change or not? If you are going to add number of moles of solvent to dilute it, will the number of moles of solute will be changed or not? What do you think?
It will change.
How it will change? See, Hamza, what I want to say is that here is solute and here is solvent and it is a solution. And if you are going to add a solvent, will the number of solute will be changed or not? Will the number of solute change or not?
It will change.
Hmm. What you just said? You don't know. Hamza, no problem if you don't have any idea about it. Let me ask me. Just see, it will change. Okay. Okay, Hamza, I'm going to take an example from day-to-day life. In your class, just suppose these are boys and these are first take girls, and here these are boys. Okay, if you will increase number of boys student, overall number of student will increase. Yes or no?
Yes.
But will the number of girls student will increase or not?
No.
No, simple. If you are going to increase the boys student, but girls are constant, that means overall the number of students will increase, but number of girls students will not increase. No? In the same way, solute plus solvent is equal to solution. For dilution, you know that for dilution, solvent added. I'm going to write for dilution, solvent added. And if solvent added, you are not going to add or subtract solute. So solute will be constant, na? It won't change.
Yes.
So see, yeah, there will be also n, that is number of moles of solute. Because for dilution you are adding solvent, number of moles of solvent will increase, but number of moles of solute will be same. I am going to apply molarity formula here. M1 will be equal to n upon V1, and here M2 will be equal to n upon V2. Again n is equal to M1 V1, and again n is equal to M2 V2. Now, are you getting it? M1 is equal to n upon V1, M2 is equal to n upon V2 or not? Are you getting it or not?
Yes, sir.
And after solving this, n is equal to m1 v1, n is equal to m2 v2, and you can see m1 v1 is the value of n, number of moles of solute. In the same way, m2 v2 is the number is the value of n, m2 v2 is the value of n, number of moles of solute. Both are equal to n, that means m1 v1 is equal to m2 v2. So whenever there will be question on dilution to find the molarity, new molarity, you can use this formula. Okay.
Yes, sir. Yes, sir. Yes,
Are you done?
yes, sir. Done.
Okay. I'm going to give you a question. Please do this question. Can you solve it?
Sure, I'm sorry.
Okay.
So what is that written? Calculate what molarity?
What are you saying?
It's written something. Calculate something molarity.
Calculate molarity.
Calculate something else is written before molarity.
Can you message in the chat box, because your voice is
Sir, something
disturbed.
else also seems to be
It's not
written
clear.
before molarity.
Still, I'm not getting. Calculate new molarity. This is new. After diluting, the molarity will be changed. So I'm asking, what will be that new molarity?
Can you solve it, sir? I tried solving it. I don't know.
Okay, just see. 0.2 m HCl and 200 ml solution initially. That means I'm going to take it M1 and this is V. Now it is diluted with 100 ml water. Just see, there is a container which has a molarity 0.2 m, and also it has 200 ml volume. Now you are going to dilute it, and diluted with 100 ml, yani you are going to add another 100 ml of water. So the new molarity will be, we are going to find out what will be the new molarity M2. This is M1 and this is V1. What will be V2? Initially V1 is 200 ml, 200 ml, and after adding 100 ml, V2 will be 300 ml. Yes or no?
Yes.
V2 will be 300 ml or not?
Yes. 200 plus 100.
Yes, 200 plus 100. So 200, 100 plus 200, that will be 300 ml. Again, this term diluted, showing that it is dilution takes place. So we have a formula M1V1 is equal to M2V2. M1 is 0.2 into V1 is 200. M2 we need to calculate and V2 is 300. And you know, we don't need to convert ml into volume, because here will be ml on the right hand side and ml on the left hand side, it will be cancelled. So m2 will be equal to, you can see, 0.2 into 200 upon 300 upon 300. This will be cancelled, 0.4 upon 3, or I can also write 4 upon 30, or I can write 2 upon 15 moles per liter.
So 0.1 moles per liter.
Yes, 0.1 something.
0.1 moles per liter.
2 divided by 15, that will be equal to 0.13. 333, it will come 0.13 moles per liter. Got it?
Yes, sir.
Okay. Now going to give you another question on this topic so that it will be more clear to you. 0.1 m H2SO4 200 ml solution diluted with 100 ml solution, 100 ml solvent. Calculate new molarity. Please do it. Take your time, but do it. Are you done with this? Or should you need any
Wait, I'm sorry.
help? Hamza done?
Sir, I got 0.06.
What is the value in fraction?
Sir, I couldn't hear you.
The value in fraction, not
20
decimal.
by
Please
300.
let me know the value.
2 by
25,
no 2 by 30.
2 by 3,
2 by 30.
2 by
Yes,
30. Okay, just see. This is M1, this is V1. And you can say M1 V1 is equal to M2 V2. Since it is diluted, M1 is 0.1 and V1 is 200. M2 we need to find and V2 is 300, yes or no? Now we know that this decimal will be cancelled by this and it will be 20. And 20 upon 300 M2. So basically, the new molarity will have a value which is 1 by 15. Wait a minute. 1 by 15 moles per liter. We can calculate it now. 1 by 15. 2 by 30 or 1 by 15 same. So it will have a decimal. It will have a value 0.067 moles per liter.
yes, I got the same.
Very good. So moving to the next topic of molarity, which is write a topic, molarity of mixture. Molarity of mixtures. See, molarity, what does this mean? You know, there is two container. The first container in which molarity is M1 and volume is V1. And here the number of moles is N1. And since whenever we talk about number of moles in molarity, it is understood that the number of moles which we are talking about is of solute, not solvent. Because in molarity, we use number of moles of solute. So whenever we talk about number of moles, that is most probably for solute, not solvent. Now there is another container which has a number of moles of solute N2, and this has molarity M2 and volume V2. Now what do you want to do? Take a bigger container and mix them together in the bigger container. Now this has molarity M, volume V, and number of moles M. Are you getting it? What happened here? There is a container in which a solution is present which has molarity M1 and volume V1. There is another container which has molarity M2 and V2, volume V2. Now we are going to mix this both solution in a single container. So this N represents number of moles of solute. So in bigger container, since I already told you that whenever we talk about number of moles, we will talk about number of moles of solute, not solvent. So here it is number of moles of solute. N in the bigger container will be equal to N1 plus N2. Will be equal to N1 plus N2 or not?
Yeah. Yes, sir. I see.
If you have any doubt, please ask me. Now see, for this container, I am going to apply M1 is equal to N1 upon V1. So N1 has a value M1 V1. M2 will have a value, number of moles of solid for this container upon V2. N2 is equal to M2. Again here M is equal to N upon V. So N is equal to M into V. Yes or no? Are you getting it? Yeah. Yeah. Am I audible, Hamza?
Sir, I cannot hear you.
Yeah, please do reply in chat box because your voice is too disturbed. I'm not getting you at all. If you have any doubt in this formula N1, N2, sir, I can't hear you. Am I audible? Am I not audible? Yes, I'm done. Am I audible? Okay. So whenever I will not be audible, please do message also. See, there is the first container which has M1, V1, and N1. I can apply molarity formula for this container. M1 is equal to N1 upon V1. N1 will be equal to M1 V1. Again, M2 is equal to N2 V2, and N2 has a formula M2 V2. In the same way, M is equal to N upon V. So N will have a formula M into V. Are you getting my point? Hamza?
Yes, sir.
Now see, can you tell me the value of V? Since we are mixing V1 and V2, so V will be equal to V1 plus V2. Yes or no?
Yeah.
Now see, I wrote this mathematical equation N is equal to N1 plus N2. N has a value M into V. N1 has a value M1 V1. N2 has a value M2 V. Also, this M is basically resultant molarity. M is equal to M1 V1 plus M2 V2 upon V. And we already know that V is equal to V1 plus V2. So M1 V1 plus M2 V2 upon V1 plus V. This is the formula for resultant molarity of mixture.
Okay, sir. Done.
Done. I'm going to give you a question on this topic. 0.2 m HCl, comma 250 ml solution mixed with 0.1 m HCl, comma 125 ml solution. Calculate new molarity.
So, sir, it should be 0.2 into 250 plus 0.1 into 125 by
Yes,
0.2
since it is mixture, very good, very good. You are going good. We will use a formula M1 V1 plus M2 V2
by
upon
V1
V1 plus V2.
plus V2. 0.2 plus
And this is just take it M1 V1 M2 V2. Yes, and just put the value. Yes or no?
Sure, done.
Done. So you can easily calculate it. It will be 50, and then it will be 12.5. Again, it will be 375. Yes. And when it will be calculated, it will be equal to.
Sir, it's 0.16.
Have you calculated it? 62.5.
Yes,
0.16.
0.16.
Very good.
Yes.
Moles per liter. Very good. So basically, this is the second last type of molarity. Now we are going to have the last topic of molarity, which is molarity of ions. You know that what is molarity of how I'm going to explain how we calculate or how we do molarity of ions. Or for molarity of ions, I'm going to take a example which will be very easy to make you understand what is how to calculate molarity of ions. Now see, 4.9 gram of H2SO4 in 250 centimeter cube solution. Calculate molarity of the first part is H2SO4, the B part is H plus, and the C part is SO4 minus. Please do. The first part you can easily calculate it, Hamza. For the B and C part, I will definitely explain it. But first, tell me the right answer of A part. Can you solve it?
Yes. Let me try. Can you solve it, sir?
What is the molarity? Hamza,
Sir, I don't know how to do it.
I don't know why it's so disturbing voice background. Are you able to solve it or not? No. Okay. It's so easy. Let me ask you a question. I'm making it easy for you. If I'm going to give you 4.9 gram H2SO4 into 50 centimeter solution, calculate molarity of H2SO4. Can't you calculate this? Yes or no? Hamza?
Yes, sir.
So what is the problem? What I just did is I needed to calculate, give you more than 3 questions. Molarity, calculate molarity of A part of H2SO4, B part H plus. I didn't tell you that calculate for H plus and SO4 minus 2. You have to calculate for H2SO4. So see, I am going to explain it. Molarity of H2SO4 will have a formula, number of moles of solute upon volume of solution in liter. See, given mass is given and volume is also given. So given mass upon molar mass upon volume 250 divided by 1000. Again 4.9 upon 98 into 1000 upon 250. If you are going to remove this decimal, it will be multiplied by 10 in denominator. Again 10 will be cancelled, and 49 2s this time, and 2 5s 10, and 5 5s 25. So the value is 1 by 5 m, or if you are going to take it in decimal, it will be 0.2 m, or 0.2 moles per liter. You can also write. Are you getting my point?
Yes, sir.
So this is the molarity of H2SO4. How we are going to calculate molarity of H plus or SO4 minus 2 without finding molarity of H2SO4? We cannot calculate or find the molarity of H plus or SO4 minus 2. Okay. So first of all, write up to this, and then I'm going to explain for molarity of ions. Done. Now see. For finding molarity of ions, we need to dissociate this into ions. Can you dissociate into ions H2SO4 into ions? Yes or no? Amjad, can you do this?
Sir, what should
Dissociation into ions, like if you are going for NaCl, so it will be Na plus Cl minus. If you are going for HCl, it will be H plus Cl minus. Are you getting my point?
yeah, yes.
So see, since H2SO4 is acid, so it will give H plus and SO4 minus. Again, for balancing, there is 2H, so I'm going to multiply it by 2. So this is the dissociation equation for H2SO4. Okay. Are you getting my point, Amja?
Yes, sir.
Now see, you have studied in class 11 about stoichiometric coefficient. 1 mole of this will give 2 mole of this and 1 mole of this. By comparing, what is the stoichiometric coefficient? 1. What is the stoichiometric coefficient? 2. And what is the stoichiometric coefficient? 1. So 1 mole of this will give 2 mole of this and 1 mole of this. Are you getting it?
Yes.
Now see, in the same way we do molarity. 1 molarity, since it has 1, will give 2 molarity of H plus and 1 molarity of SO4 minus. Are you getting it? 1 molarity, 2 molarity, and 1 molarity. We did in the same way that for we did for 1 mole. Hamza.
Yes, sir.
Now see, what is the, you can see, if 1 molarity of H2SO4 is present, then double of molarity of H2SO4 H plus H2SO4 will be formed is equal to molarity of H plus. That means whatever is the molarity of H2SO4, the molarity of H plus will be double because the ratio is double. Are you getting it? And 1 molarity of H2SO4 will give 1 molarity of SO4 minus 2. That means whatever is the molarity of H2SO4 will be equal to the molarity of SO4 minus 2. Yes or no? So basically in this 1:2 ratio and in this 1:1 ratio. Now see what we have actual molarity of H2SO4, 0.2 m. So we know that 1:2, that means it will be 0.4 m, and this is 1:1 ratio, that means 0.2. And if you have any problem in this, please let me know.
Sir, can you explain that part again?
What you just said, Hamza?
I will write in this one.
Hamza, sorry, but today your voice is so disturbed that I am not getting you at all. Please do message me. Okay, yes, I can explain that part again. See, this is H2SO4. Can you write its can you write a equation in which it will be dissociated into ions and balanced? Yes or no? After this, if it is balanced, the way you compare mole, like this has a 1, this has 2 stoichiometric coefficient, this has 1 stoichiometric coefficient. So 1 mole of this will give 2 mole of this and 1 mole of this. In the same way we do for molarity. At the place of mole, we take 1m, capital M, 2m, and 1m. Okay. Now see, this is general. If 1 molarity of H2SO4 will be there, then this will be 2 molarity and this will be 1 molarity. But we know that we already calculated H2SO4 have a value 0.2 m. So you can see this has a ratio 1:2 because 1 is giving 2, that means double, and 1:1, that means this molarity of H2SO4 is equal to molarity of SO4 minus 2 because their stoichiometric coefficients are equal. That's why its ratio is 1:1. Now see, if it is 1, then the molarity of H plus is 2. If it is 0.2, then the molarity will be 0.4 m. Why? Because it will be doubled according to the stoichiometric coefficient rule. Again, if it is 1, then it is also 1. So 0.2, it will be also 0.2. Please write. And if you still have any problem, please ask me. Very good question. Hamza, this is generalized. Basically, one is what we, oh, wait a minute. Have you studied in class 11th stoichiometric coefficient or not? Stoichiometry.
Yes, it's the coefficient before that. For example, 1.
Basically, this is not changed in this. This is the value we have. H2SO4 has molarity this much, and according to this, we need to calculate this. This is general. General, that means its stoichiometric coefficient is 1. With this 1, 2, 1, we are going to find a relation. What is the ratio between this, and if 1 mole of this will give 2 mole of this? Are you getting my point? Let me tell you again. No problem at all. See. See, okay. Hamza, tell me the stoichiometric coefficient of H2SO4. 1. Tell me the stoichiometric coefficient of H plus 2. Very good. Stoichiometric coefficient of SO4 minus 2. 1. Very good. Now see. This is basically 1 mole of H2SO4 will give 2 mole of H plus and 1 mole of SO4 minus 2. Are you agree with this? Just reply with me. Are you agree with this?
Yes.
Or not? 1 mole of H2SO4 will give 2 mole of H plus and 1 mole of SO4 minus 2. Are you agree with it or not? Yes. But this is generalized. What we have is, just suppose we just calculated number of moles 0.2 mole of H2SO4. What will be the moles of H plus formed here? Can you tell me what will be the number of moles formed here? If 0.2 mole of H2SO4 you have, what will be the number of moles of H plus here? Can you calculate it or not? Let me know. 0.2 plus 0.2. You can see 1 is giving 2 moles, so 0.2 will give 0.4. Again, what will be the moles of SO4 minus 2 formed? Since 1 is giving 1, so 0.2 is giving 0.2 mole. In the same way, what I did, 1 molarity I take for general, it will form 2 molarity, it will form 1 molarity. But actually, this is for general information or generalized, for generalization. But we had only 0.2 m H2SO4. For 1 molarity, it is 2 m. So for 0.2 molarity, because we calculated the value of moles of H2SO4 is 0.2 m, so it will be 0.4 m. It will be 0.4 m, and again it will be 0.2 m. Now got it or not?
Yes.
One we used is basically from the equation, general equation. Should I slide it up? Please do it correctly. Oh, wait a minute.
Well done.
Very good. I'm going to give you a question on this topic also. Uh, the question is basically 7.1 gram of Na2SO4 present in 100 ml solution. Calculate molarity of Na2SO4. The B part is Na plus, and the C part is SO4 minus 2. Please do. Will you be able to solve it or not? Anja?
Sir, I got 0.005.
Which part? A 0 point what?
0.005.
Please do assess. 0 point target. I didn't hear you. So 0.005. Let me check. Molarity of Na2SO4 given that is number of moles of solute upon volume of solution in liter. Number of moles that is given mass. What is the molar mass of Na2SO4? What is the molar mass you have taken for Na2SO4? 142 upon volume of solution 100 upon 1000 for liter. Again 7.1 upon 142 into 1000 upon 100. Again 20 will be cancelled by 20, and if you are going to remove the decimal, it will be 10 in denominator. Again it will be cancelled. Now this is basically 71 upon 142. So it will be cancelled by 2. So the answer is 0.5 moles per liter only. Check your mistakes, please. Check your mistakes and tell me where you have mistaken. Are you done with it? With this, have you seen your mistakes? Hamza, am I audible? Hamza? Yes. Okay, so have you checked it? Your answer was 0.005, but my answer is 0.5 m. This is the difference. Where you have mistaken, please check it. Now, can you calculate the molarity of Na plus and SO4 minus 2, Hamza?
Yes, sir. And A,
Okay, please. Yes. Please do it. B part and C part. Yes. So, what is the molarity of Na plus?
Na plus is 1.
What you just said? 1.
1.
Just write in chat box. Are you telling me 1? Okay, this is wrong answer. Let me see you. Let me tell you. First of all, you will dissociate into ions like you did. This will be Na plus and this will be NSO4 minus 2. But you have to balance it. Now it is balanced. Are you getting my point? Now it is balanced. Now see, 1, here it is 2, and here it is 1. 1 molarity of this will give 2 molarity of this and 1 molarity of this. But the fact is that we have 0.5 m Na2SO4 is given. We have calculated. That means double of this will have 2 5s 10. That means 1 molarity and 0.5. Very good. Hamza, you have done this.
Yes, sir.
Okay, very good, very good. So can we move to the next part? This is how we calculate molarity of ions. Done. Can I change the slide?
Yes, sir.
Okay. Now see, we have molality. And what is molality? So basically, number of moles of solute per unit mass of solvent. This is the only concentration term in which solvent is used in denominator. Apart from this or except this concentration term, every concentration term in their denominator we use solution, but this is only the concentration term in which we use solvent in denominator. So molality is basically number of moles of solute upon mass of solvent in kg upon mass of solvent in kg. Now we can also write its unit. Unit is moles per kg, or we also write m small. Please write. Then I will give you a question on same. Are you done with this?
No, sir.
Please do it.
Sir, can you do it, please?
What you just said, Hamza.
Sir, can you do article given on today?
Okay. See, I'm going to explain it. We need to calculate molality. So this is it, basically number of moles of solute upon mass of solvent in kg. This is understood mass of solvent. Now see, solute is given and solvent is also given. So this is given mass upon molar mass upon mass of solvent, which is 90, and we in kg, for kg we are going to divide it by 1000. So going to simplify it. So it will be like this: 1000 divided by 90. Again, this 0, this 0, this 0, this 0, this. Oh, I made a mistake. This will be cancelled, and you can easily calculate it. 100 upon 36, or 4 9 ja, 425 ja. So it will be 25 by 9, a small m, or we can also write 25 by 9 moles per kg. Are you getting my point? This is the molality. Okay.
Yes, sir.
Okay. So this is it for today. We'll see you in the next class.
Yes, sir.
Okay. Thank you, Hamza.